Howdy 216ers, this is Professor Kaufman, and what follows is an overview video of your first project. This project's going to see you building a C application of modest size. It'll employ all the skills that we've been discussing in lecture pertaining to C syntax and semantics. That includes things like working with C structs, doing some dynamic memory allocation, reading in data from files, and so forth. The project is divided into 3 different problems, and we'll talk briefly about what each of those problems entails. But the design is such that you build up an application that actually does something. And we'll take a few steps here to demonstrate how to get started for those who are just a little bit intimidated by a very long wall of text, which is this rather lengthy specification. If you grab the little scroll bar over here, even with the somewhat larger text size that I'm using for the video here, you can see that there's a lot to digest in this. Now rest assured, some of this stuff is actually not terribly important. Down here is some submission instructions, including some broken links to images that I'll fix as soon as I'm done with this video. And up here is stuff that if you've been tracking along in discussion, you'll already be vaguely acquainted with. The fact that we'll provide you a makefile, and the makefile builds into the make system so that you don't have to hand compile everything yourself. And in addition to that, like in the discussion exercises, there are a bunch of automated tests so that eventually you can type make test prob 1 or make test prob 2 and such in order to evaluate whether your code is functioning more or less correctly. Just a quick hint, if you forget about what commands are available from the makefile, type make help and they'll get a little listing here of the things that are supported. This isn't universal to all makefiles, but it's a convention that I'll follow in here, and we'll actually use a few of the tricks in here to make sure that we're coming along okay. Most of the projects will start with a little manifest that concerns what files are present in the project and what you are to do with them. For instance, you'll notice here that there's a makefile provided, and it's labeled as provided. You don't need to change anything here. Some of the files are pertinent to testing, and then there are a few that you're provided but will need to edit in order to complete things. And so this is going to be similar in many ways to what you have been up against in discussion. And the primary 2 that you'll be editing are this stockfuncs.c and stockmain.c, a bunch of utility routines that you'll write and complete for the first couple problems, and then a main function that you'll need to complete for the end of the project, problem 3. Okay, the gist of the applications you're going to work on is to do a little bit of ASCII plotting for things. And the best way that I know to demonstrate what this looks like is to show you what it will look like eventually. And so I'll jump ahead to problem 1 here that contains an overview of the program that you'll eventually complete. So as you would have finished everything in the project, you'll be able to type make and get yourself a stock main application. And stock main's intent in the world is to read in little stock files like this in the data subdirectory stockascending.txt. We'll have a look at what that file looks like in a second. And I want a printing height of 10, a max of 10 here. On getting that, the application will execute a bunch of functions to do the following. It'll read in data from this stock ascending file, do some assessment of it, and find out, oh, there are actually 10 prices listed for this stock over time, and the prices start out 10, 20, 30, etc. The lowest price index is at index 0, the highest is at index 9, and that would mean the best time to buy is right at the beginning and sell right at the end, which would net you a profit of 90 bucks if you sort of bought and sold at those times. And then to plot that data out, and you'll see this little ASCII rendering of the plot down here where there are axes tick labels. Apparently the lowest price is 10, that's mentioned up there, and the highest price is 90-ish bucks, and the 91 tick mark here is fine. The bars here correspond to, there's a low price here, and then it went up a little, and then it went up a little more, and up a little more, and these axes marks indicate that. This particular bar is drawn with an L because it's the lowest. All the unimportant bars got stars on them, and then the highest one is over here labeled with an H. And you'll notice this little buy here, sell here business that we'll monkey around with later on. Now the height here is adjustable so that if you were to call this with some additional arguments and say actually only print at 5 high and start at time index 3, end at time index 10, then we get a little subplot here where you see, oh, I'm not starting at the very beginning. I've squashed this 10 high graph into instead only 5 high. And since I'm starting later on in the game at time 3, I don't actually see the buy point or the low points. It's just the tail end over here up to it. You can look at other spots to see like, oh, here's another stock. It's a valley that's where the price starts out high and goes low and then goes back up high again. And clearly there'd be no point in buying early on here. You'd want to buy at the lowest point and then sell at the highest point if that's viable. And you notice then like, oh, the buy-sell part is demarcated up here and this is over here. Now, if this is seeming, easy, then well, awesome. If it's seeming a little complex, that's fine. What we'll do is, within the context of the project, implement a series of functions that pieces out each of the little pieces that needs to be done here. For instance, there'll be something that detects what is the low and high point, that figures out this is the best time to buy, this is the best time to sell, and then a somewhat involved plotting routine that actually puts this on the screen there. There are functions that you'll write for each of these. And so to that end, this has got some smacks of problem decomposition into it so that you don't have to write one big, giant, long function that does everything at once. It's generally expected they have a little bit of experience at this point decomposing problems into functions, but not a tremendous amount. And so, for instance, for these first couple projects, we'll give you a decomposition that you have to follow and test cases associated with each of the functions that you have to write. Perhaps later on in the semester, there'll be a little bit more liberty to start working on those things and decomposing them according to your own tastes. You are always free to write helper functions of one sort or another, but down below all the demo stuff here, there is a listing of the functions that are required from stockfuncs.c. You'll have to write things like, oh, create a new stock, allocating memory and initializing it to default values, as well as freeing that memory at some point using a stock free function. There's a stock print function, there's a stock load, and so forth in here. This listing is already laid out for you in the template that is stockfuncs.c, but it's useful to have a reference for them over here. And bear in mind that in the future, we may say create this file, at which point, oh, it's super easy to sort of get the required functions by copying this little listing into it and then starting to crank away on those functions. If you should want that set of provided files straight out of the gate, the stuff that's in this listing over here, then you'd want to download the zip over here. And since I've rambled for a little while, I think it's probably a good time to actually get the coding on this part. As we've done in the past, we'll work on Grace, as this is a Linux system that's accessible to all of you. It requires some remote login to work with, but this is excellent practice for the future when you'll probably have to work on remote systems at times. Over here, I've already logged into Grace, and I've used an SSH to do so, so I've got a terminal there. If you happen to be on Windows, then you'd want to make use of MOBA Xterm for some minor conveniences there. If you're on Mac, then you'd probably use Xquartz and do something similar to this. I'm on a Linux system, and so what I'll do looks kind of like what you do on Mac, because we'll be launching some graphical applications that show up as Windows on my system here. It happens that if I use this -y option to SSH, I get the forwarding of graphical applications, and this -y seems to speed it up in my case. So experiment a little if you're on Mac. MOBA Xterm folks probably don't need to worry about that part. But first step, of course, is to get the code that's provided in the code pack on there. Let me change over to my CMSC216 directory. You'll see a listing here where I have been working on discussion 1, discussion 2. Now it's time for project stuff. I'll make a copy of this link. And let's see, do a wget in here. Let's see, paste it on. And that should download the starter pack. So if I do a listing now, I'll see the P1 code over here. I'll want to unzip that. So here's P1 code zip. And then I'll change into the created If I list here, you'll see the blue P1 code directory here. So I'll change into that. And then as a listing here, you'll see all the usual characters. There's some testing files, there's a make file, and then the provided stuff like the stock funcs.c, a stock main. There's also a header file that we'll want to look at because there'll be some structs that we'll need to monkey around with. The stock demo.c is provided and shouldn't need any modification. It's used to demonstrate some of the things that those stock functions are good for and so forth. And the data directory here, if we list what's in there, you'll see there's a whole bunch of these stock files that are in there, including some actual prices for corporations that are near and dear to our hearts. That function is part of the test cases at some point. Okay, with that there, we should probably start rummaging around some of this stuff. For instance, we were just talking about how this stock funcs.c, this is the primary one to edit. And so I will fire up a graphical editor. gedit seemed to be running reasonably fast over here. And so I can pull that over. And then I'll open up some other documents here. Looks like it positioned me in P1 code, so I will open up stock funcs.c here. Let me see if I can increase the text size here just a little bit for readers at home. Let's see, the fonts and colors. I don't want to use a system font. 12 is good. How about 14 though? All right. You know, it's a little bit gaudy, but no matter on that account. Move you over here, and we're good to go. So within this file then, you'll see the list of functions that you are to write. You're free to add on to this if you want, but this is a sort of minimal implementation, and most folks probably don't need to go much beyond it. Each of the functions has a documentation comment of sorts, which indicates what you will need to do when the function, for instance, this stock new, is to allocate a new stock struct, initialize its fields to the following kinds of values. Integer fields that are within it, like count and low index, should be -1. Pointer fields like prices should be null, and should make sure that this is a heap allocated thing, so if you want to make use of malloc. And since this is a creation function, you won't use free. Now, the first thing that might strike you on this is like, well, that's great and all, but how the hell am I supposed to know where this count and this low index stuff come from? One of the conventions in C is that whenever you need agreement between multiple implementation files, .c files, on this is the shape of this struct, or this is the prototype of this function, you place it in a header file. And one is mentioned here, stock.h. That typically contains information then that is included in other C files so that they're all in agreement about what's there. And it's worthwhile to open up this stock.h file right now. So I will pop that open, and here's stock.h, and notice I get a little tab in here. And here's the typedef for that stock t. This follows the same basic pattern that we described when we talked about setting up structs, these sort of recipes for new data types that we'd want, and this one is no different from that. It's called a stock t, set up with a typedef, and it has the following fields of the struct. There's some integers here like low index and high index, and best buy and best sell. There's a pointer to an array of prices that's over here, and this is what will be read from some of those data files in there so that they can be processed. And then a size for that array, because again, as you would malloc this array, you need to keep track of how many doubles are actually in there. Arrays don't carry that on their own, so typically there's some other field associated with a count or a size or something like that. Finally, there's a character pointer here to say that it's typical to load up data from a file for these stocks, and so it'll track which data file that this came from. In addition to that, there are a bunch of functions listed here so that any other code that needs to call some stock-related functions, for instance, a main function that's in a different C file, knows that those functions exist. And so as you'd be doing things like including standard io.h, etc., this is the same basic thing to make the compiler aware that there's going to be a printf or a scanf or an fopen function and so forth. So this is the header file. It's good to refer back to it occasionally if you forget what fields are in there and what they're good for. To that end, we've got this stock func, so we can start writing stuff in here, but it might not be a bad idea to acquaint ourselves with a few other sort of items on the agenda of how we'd want to make progress. For instance, if I'm forgetting how to make things, I might type make help over here, and then I get the little listing of like, oh, I could build all programs, I could create a final zip for uploading and so forth. I could try to build programs just associated with the first problem, run all the tests, run one of the tests, like test prob 1, prob 2, etc. I haven't written much yet, so but we may as well just see, can I run the test associated with problem 1? And the answer is yes. This is provided out of the gate as like it'll run fine there. Unfortunately, over here, we're not doing much by way of passing anything yet, and that's sort of expected since we haven't written anything yet. But you'll see the tests over here, they each strongly indicate that they are associated with one of the functions in here. And so constitute what's more or less unit tests, like, okay, this test is for this function, these 3 tests are for this stock free function, etc. And so one of the things that you'd probably want to start doing is like, oh, let's just see if we can crank out some code for this stock new. Since this is your first project, we may as well do a little bit of that together to get you off to a good start. So this says I should allocate space for a struct, a new stock struct, and then initialize its fields to various things over here. That allocate stuff makes use of malloc, so I'll have to remember semantics associated with that. Eventually, I'm going to have to return this stock according to this stuff, and so it's logical to sort of lay out a pointer to one that I'm going to malloc. So I'll call this stock t star the stock. And I'll have to malloc some stuff. Here's where you need to remember, okay, the mallocing part of this is I have to ask for the correct number of bytes. I could do something semi-inane, like, okay, I think that the number of bytes that I'm going to need is going to be a pointer plus an int size plus another pointer plus these many ints. Or you could do the slick thing and realize, oh, the size of operator, this will calculate sizes for you. The compiler will do it for me. And I just have to say, what do I want the size of here? Now this will bop back a pointer to enough memory that's over there. And at that stage, you'll be ready to start filling in stuff. Now for the uninitiated, then you might have some trouble and do something like, oh, I'm supposed to set things like this count to be -1. So it'd say the stock dot count equals -1. I might try and save that here. Looks like gedit's gonna warn me about a bunch of stuff. So I locked gedit over here, but it's still printing any error messages it sees over here. But no worries on that account. Just press enter a couple times to get your terminal back. And now I might just do something like, oh, let me run the test here again to see how I'm doing here, and find that in order to run the tests, this changed code needs to be recompiled. The compiler is not liking too much the syntax that I have used over here. In fact, it's specifically saying this stock.count business is suspicious because the stock is a pointer. And it's offering a suggestion. Did you mean to use the arrow instead of a dot? And then you're like, oh yeah, the count here should be accessed with an arrow because I need to dereference the stock pointer, but to get to chase that pointer into the heap where the stock is actually at, and then access the count that's over there. Saving that change over here will probably generate some more gedit complaints, but no matter. But at least at that point, I could like run this thing and see, oh, well, cool, it's actually running the tests again over here. Now you notice I didn't make a ton of progress on this. I'm still failing. It might be worthwhile to know why I'm failing. And to that end, this file is going to tell me like what's going on with that. There are a couple of ways to access it, but since I've got a text editor open already, I may as well just open that up. It's under these test results, and since I'm working on trying to pass that first test, this problem 1, test number 1 here, I can open this thing up. And maybe I'll maximize this so I can actually see it. And you'll see the dreaded segmentation fault over here. If I scroll down a little ways, you'll see that there's a Valgrind report below this. And the general failure messages up here are useful. For instance, there's a mention here of there's a segmentation fault and the output matched. That's typical, that if you seg faults go out of bounds in memory right in the middle of doing stuff, it's likely your output is going to match. But nothing's going to work until they fix this seg fault at some point. And the Valgrind report that's mentioned down here gives some hints here. For instance, it's talking about, oh, there's a testing file. It's being tested here, and line 38 is where the problem is. So it'll probably be worth our while to look at this test stock funcs line 38 over there. There's another hint here mentioning, oh, there's an invalid read of size 8. And this is where your knowledge of C kinds of things can start to come into play. This is either going to be a long or a pointer of some kind. As in, that's the two kinds of things that are size 8. Doubles are as well, so I guess that's another possibility. One final hint, this mentions address 0. And this is almost always a null pointer. And so what we'll look for at line 38 is like, oh, maybe I'm doing something with a pointer at that point, and the pointer is actually null. So let's open up that stock funcs.c. Lest you think that there's an error in the tests, this is likely something that's being returned that's incorrect from the code that we just wrote. And it's then the problem of the code that we wrote rather than the test. The test is just detecting that problem. So let me open that part up here. So I'll need to come back up into P1 code. So here's the test stock funcs.c. We're looking here for line 38. Down here in gedit, this is where the line number is. There's probably some way to turn on line numbers here too, and may as well look for it because those of you who are going to be using it may find it useful. Let's see. Enable annotation, fonts and colors, view, display line numbers. Fantastic. Okay. So here is line 38. Now, as you would look at a line like this, you look for what are the possibilities for a seg fault here. Where am I dereferencing a pointer that may be going out of bounds? And clearly what's happening in the test is, oh, my stock new function that I haven't quite finished yet is getting called. And then we're immediately dereferencing to say, let me look at the parts of it. Well, if you return something incorrect, like a out of bounds memory address, the first attempt to dereference to print here is going to seg fault. So go back to stock funcs and check to see what's happening in that. Let's see, I malloc this thing, I set one of the fields, and then like a moron, I just returned null. The correct thing to do at this point is, oh, I created some space. I want to return this fresh stock that I have created. So I need to return instead the stock rather than null. So that's a save. And maybe a try again over here. So I'll maximize that again. And maybe I'll take test prob 1. Now it takes a while to run all these tests. And so I might sort of save a bit of time if I run an individual test. Can't remember exactly how to do that, but I know someplace in there's a documentation for that. For instance, make test which test problem you're doing, and then you can pick a specific test down here. Handy advice there. So I'll do a make test prob 1 and then test num equal 1. Interestingly, then this does a couple things. It will spit out and run that single test, producing the output file as well, but also show you on the command line the results for that single test so that you can have a tighter loop to look at things out there. We come back up and looks like the seg fault is gone. Up here it says there's still some Valgrind problems that are mentioned, and we may need to attend to those down here. But more importantly, I'm actually getting output over here, which is great. So the stock data file looks correct. Hey, that count that I set is -1. That's good. The stock prices is nil, null pointer, whatever it is. Looks like each of these low index, high index, etc., they're supposed to be -1, but right now I'm printing out zeros. Oh yeah, I didn't even initialize those yet. So that's probably why they're getting lucky and they're 0, but I should initialize them in that regard. So cool, okay, that's good. I know what to do at this point. I can come back over to the stock funcs here and do things like here, the stock arrow low index equals -1. And then I'll copy that and do this as high index. should probably not spell it indux, but index instead. So here's best by and probably best sell, something like that. Cool. Okay, so that's a good start. And just to check that I got the names right here, best buy, best sell, best buy, best sell. It's good. Okay, cool. I'm feeling good about that. I'll save it. And as you would make changes on Gedit, at least you'll see some little symbol next to the name up here to make sure that's written to disk. And then you press save or Control S. If I just undo that, we'll get back to state here. So I'm ready to try that again. I can, press enter a couple times to get this back and just rerun the one test here. Up here, I see something kind of interesting. The test ran. The output part has disappeared, and all I see is Valgrind errors. Now, essentially what that means is the output is correct, but Valgrind is not particularly happy about some of the things that I'm doing with memory and so forth. So, for instance, over here, there's a mention that there's a conditional jump or move that depends on something that's uninitialized. There's a sort of trace here that this was detected at test stock funcs line 38. If you'll recall that we had pulled that up before, that's line 38 of the tests over here. It's this printout over here of data file. That was printing as nil before, which was apparently correct. But then I do another faceplant and remember, oh yeah, I never actually initialized that myself. It happened to be null, but I never set it in here. And if that space had some arbitrary other data in it, then I would match the output and I'd still be using an initialized thing. Valgrind is smart in that it even will say, hey, the initialized value that you were accessing was allocated using malloc on the heap, and it was allocated here, that stock funcs line 12. If you look back over here at line 12, it's like, oh, that was where I malloc stuff. But there are a bunch of parts of this stock T that I didn't actually initialize. Let's plop those down now. So as I don't forget, they are, let's see, there's I'll make this a little bit wider, a data file that I want to initialize. So let me right here, copy that thing and say the stock arrow data file. Now that's a pointer, and it's typical to have some initial thing to point at. In this case, we're advised those should be nulls. That's mentioned up here. The pointer fields like prices should be initialized to null. And that's a good reminder as well. Then there's a stock, it's called in here prices. Prices, so we'll add that on. Prices equals null. Okay, that's a save. Did I miss any fields on here? 1, 2, 3, 4, 5, 6, 7 of them. And I've got 1, 2, 3, 4, 5, 6, 7 in it. So I'm feeling pretty good about that. At this point, let me run that first problem. And oh my God, one test down and more to go. So that's your basic cycle, which in this case was pretty simple to solve because it's just a matter of initializing some values, but will get progressively more complex as you move ahead. For instance, as you move ahead, this free function is probably not going to be too bad. There are a few notes here about like, oh, since I have some pointers to things over here, like a data file and a prices, I want to check and possibly free that memory in case it was malloc as well. To that end, just make sure that you examine these carefully, and as well as you run tests associated with each of those functions, examine the output of the test to ask what the test is specifically looking for, and check the Valgrind reports very carefully because they can give a lot of insight to where to look as you would want to correct your code and to make changes to it. So the remainder of the project then has you engaging in various things. For instance, as you move ahead, you'll fill out the functions for the first few to be able to allocate and deallocate stocks, as well as then load it from a file. I want to make sure to draw your attention to the implementation notes that are present throughout the spec. These are advice and techniques that you are very likely to need to be able to use. For instance, some of the things that we already ascertained, they're actually described over here. Like we'll need to use the arrow instead of the dots. And you'll need to malloc things and make use of that size of operator and so forth. Here are some notes that pertain to how to deallocate properly. That pertains to the next function. And one of the next things that you have right is printing functions. And so there's some advice as well about how to implement this function. There's some special caveats to like, oh, if the amount of things that you have in the prices array is 0 versus 1 versus 2 versus many, here's how you might structure your code in order to attend to those things. There are a couple options, and you'll just want to sort of take that there. Once you get finished with this set of stuff, certainly you'd want to run the automate tests to make sure that they're mostly passing. You may be also cognizant of the fact that there are manual inspection criteria for each of the problems. These would be things like basic style, so that you're not creating horrendous looking code with terrible indents that makes it hard for readers to follow, as well as you'll want to comment a few parts here and there to indicate the choices that you made. Now, we're not going to be super rigorous about this part, but anything that you want to remember yourself, you're like, oh, it took me a little while to figure that part out, it's likely that you'd want to have some comments for it. And the general rule of thumb is, anything that's, longer than 10 lines, you'd probably want some commentary about that, at least a comment or two. And snaky bits of code, where like here's a big block with a complex loop, at least a few comments in there to state what's happening at each stage there is good. Okay. As you'd move on to problem 2, these will be somewhat more difficult problems that involve some looping, and in particular, finding this best buy sell index is a slightly interesting problem. There's an algorithm with some pseudocode given here, but later on there is an optional makeup credit endeavor wherein you can code a more efficient version of this that is linear in time instead of quadratic. Makeup credit helps you so in that you can get more credit, like 110 out of 100 points on the project. That 110 then makes you robust against if you lose credit in a future project. Those 10 go into your project pool, so you can make up some credit there. It will not provide any extra credits, so that you can get some amount of credit overall for projects. I believe it's 20%, but no more than that here. Still, it provides a little challenge, and for those of you who are mathematically inclined, you can attempt that problem. Just make sure that you do the quadratic version first so you have some working code for that and pass all the tests before taking on the optional version of it. Now, where many of you will start to encounter some more difficulties is when you have to deal with file I/O and read these stock files in. So the first properly challenging function is this stock load, which is designed to read one of the stock files and populate the data associated with a stock with that, rather than sort of how the tests manually plop things down. Stock files have a simple format. They generally are 2 fields per line. So there's a time field and then a number, which is the price of the stock at that time. We don't do anything fancy with the times. They can basically be ignored. And it's useful to know something about how to ignore fields as you're reading, but there's some tips on that later. The first and most important thing to recognize is that there's nothing in this file that sort of gives any indication of how many prices and times there are going to be. Just that, for every time there's a price, every time there's a price. So as you would want to read this in, a common strategy is like, well, I know the format of this is that there's one price per line. And so you go through and count how many lines are in the file, and this will indicate if I want to read all the prices in and work with them, then I will count lines first and then allocate an array that is large enough for that. So the next few functions are in support of that. For instance, you write a little counting lines to process those files, and then start to work on that load stock function. Which would call count lines, allow you to allocate some data associated with the stock, and then start reading each of these in. For instance, there's a mention here of like how you can skip over things like the time over here as strings using fscanf. So super useful implementation note for you. The final coup d'etat of this second problem is the plotting function itself. And this will take some time for all of you to work on. The basic premise is to print out some data about the stock, but then to print out, here's what the plot is going to look like. The meat of it being printing these little bars and these axes labels and the little horizontal axes ticks and so forth, and get every little detail right on this thing. There are quite a few notes about this, but I think the most important one to recognize is this is a printing endeavor that you typically like to sort of print upwards, but in most cases you cannot do that. Terminal output has you printing across a line and then moving down to the next line. This means that it will be extremely useful to analyze the pseudocode for this vertical printing over here and follow that with some amount of detail in the code that you write to do this vertical printing. As well as that, there are a bunch of tricks on here about how to print out the axes labels and various other things according to that. Do some reading, get some help from TAs, and you should be fine in this. The last problem, which starts down yonder, is to just complete this whole endeavor by writing a main function, stock main. We should pull that up just so that you're aware ahead of time of it. So stock main is also provided. It's here. But it is incomplete. So you'll notice here a number of required sections. There's a description of what you should do in this section, and then you'll write the code for it. And then write some more code in this required section, and this gradually builds out the required functionality of the main function. A couple important things. This will have you processing command line arguments. That the general usage of the program is you call your stock main, you provide a stock file, a max height, as in how tall should those bars be, the scaling of it, and then optionally a start time, like a start index, like start at time index 5, and a fourth optional stop times, like so you can print out a little slice of the stock prices there. So this main will have you working a little bit with processing those command line arguments. They always come into C programs using the main's prototype, the argc and argv array. This is how many things appear on the command line, including the program name. And this is an array of strings that you can access the zeroth, the program name, the oneth, the twoth, and the threeth and fourth things optionally there. So there's some description in the project spec about how you might employ this to sort of say, oh, if I needed to check if there are more than 2 or more than 3 or more than 4 arguments, I could do so. If I wanted to go through and print out all those arguments or otherwise work with them, there's advice on how to do so here as well. As you would be ready to submit, you type the following in a terminal, make zip, and this will create a zip file, in this case p1 complete.zip, and this is to distinguish it from the p1 code, which is the starter code out there. This is what you'll want to get onto your personal machine so that you have a copy of it. We've gone over instructions for that like SCPing or in MOBA Xterm, right-click and download it, and then upload that to Gradescope. There, the automated tests should run associated with it and should reflect what you get as you type make test on the Grace. That those two systems are similar Linux systems and so should produce the same results. If you're seeing differing results, I'd want to know about it because that would be somewhat of a mistake. The Gradescope submission won't be open for a few days because it takes me a while to set up the auto grader for that, but probably by lecture on Tuesday next week, we should be in business for that. So you can start submitting or at least experimenting with submitting. A final couple words. Most folks who have worked on projects that I've written before have found that if they start early, they end happy. If they start late, it can be extraordinarily stressful as they'll have to burn some engagement points to submit late because it was longer than they thought it was going to be. Just make sure to get a handle on this. We've covered everything in lecture that is required to complete the project at this point. And folks often ask, like, why is the project worth so little? It's going to be worth about 4% of your overall grade. Well, that's because this is generally practice, and it prepares you to do things on the exam. Exam questions are oftentimes based around techniques that you'll practice on the project. This will include things like working with I/O, working with structs either as pointers or as actual structs, possibly debugging things using output that Valgrind provides. So long as you work on the project, you'll probably be in great shape come exam time. That's all I've got for the moment. Happy hacking to you, and I'll see you in lecture next week.